6-1, solving systems of equations by graphing. A system of equations is just a set of two or more equations with the same variables. So they have to have the same. So if you have x plus y, x and y, so a system would be like y equals 2x plus 4 and y equals 5x plus 7. That would be an example of a system of equations. In this course, you will focus on systems of two linear equations. Nor a pair that is a solution of both equations is a solution of the system. So it has to work for both, otherwise it's not, it would not be a solution. And when you're looking at solutions to a system, it's where the two lines meet. A system of linear equations can have one solution, means it crosses in one spot. They could be infinitely many solutions, which means they're the exact same lines, they cross every single part. Or it could be no solution, which means the lines are parallel and they do not cross. A system of equations is consistent if it has at least one ordered pair that satisfies both equations. If it crosses once or more than once, it's considered consistent. If a consistent system of equations has exactly one solution, it's independent. So it would be consistent and independent if it crosses exactly once. If it crosses more than once, then it would be consistent and dependent, which means the lines are the same exact line. And if the lines never cross, they are inconsistent, which means the lines are parallel. You can tell if lines are parallel because the slopes would be identical. So our first example, use the graph to determine the number of solutions the system has, then state whether the system of equations is consistent or inconsistent, and if it's independent or dependent. Just know that if you say it's inconsistent, it's neither independent nor dependent. You only use independent and dependent with consistent. So letter A, y equals negative 3x plus 1, and y equals x minus 3. You can see in the graph here in the coordinate plane that they do cross. They cross in one spot here. So because they do cross, this would be consistent. And it crosses in one spot, so there is one solution. Because it's consistent and it crosses in one spot, this would be independent. So one solution, consistent and independent. Letter B, we have y equals half x plus 2 and y equals half x minus 1. And see that the lines do not meet. There are no solutions. There are no solutions here. And because they do not cross, this would be inconsistent. Next example. Complete the system with another line from the graph so that it is consistent and independent. That means it only crosses in one spot. So we have x minus 5. X minus 5 is the green line in our coordinate plane, and it has to cross in exactly one spot. We have two lines here that crosses in exactly one spot. So if we look at this place, the blue and green match up. So we would have the blue line, which is y equals negative 2x minus 5. That would be one system you could use. It also crosses here, which would be the red line, and the red line would be y equals negative 2x plus 3. And then you can't see that it crosses, but this gold line or this orange line continues down here. This green line is going to continue this direction as well. So they are eventually going to cross. So we can use that line as well, which would be y equals negative 2x. The orange one would be y equals 2x plus 3. So all the lines would cross at some point once. This bottom one, complete the system with another line from the graph so that it is inconsistent, which means that they do not cross. And one way to tell check without even looking at the graph is that it has to be one with the same slope. So if I look at all my equations, ones that have the same slope, we have this 2x, negative 2x plus 3, and we have this negative 2x minus 5. So the blue and the red lines don't cross. The red line is the one that we were given, so we're going to write the equation of the blue line, which would be negative 2x minus 5. Next, determine whether each graph shows a system that is consistent or inconsistent, and if it's independent or dependent. So this one, first one here, I can see that the slopes are the same. The lines never cross, so this would be inconsistent. The other one, we can see that it crosses once, and because it crosses, that's consistent. And because it crosses exactly once, that would be independent. Moving on to the next part, you can solve a system of equations by graphing each equation carefully on the same coordinate plane. One thing that you have to make sure is if you're drawing it out, you need to make sure you are as accurate as possible and you're using the same intervals and you label your axes. Every point that lies on the line of one equation represents a solution of that equation. Similarly, every point on the other line represents the solution of that equation. Therefore, if it's a point that's on both lines and it's the same, that would be a solution to those because that is where the two lines cross. So in this example, I have a point here, negative 1, 3. That's a point on both equations. So this would be a solution to both equations. For example, so we just went through that one. So we have negative 1 and 3 as a solution. Now there are other points here that we could have, but those aren't solutions to both equations. That's just solutions to the red line. The only one that's on both is this one here. Let's take a look at some more information on this. So using the system of equations to solve a linear equation, first step is to write a system by setting each expression equal to y. It's easier to put it into y equals mx plus b. Then you can graph that system and then find out if and where do they intersect. So our first example of example 2. We'll graph the system and determine the number of solutions it has, and then if it has one solution, then we have to determine what the coordinate would be. So since both of these are in y equals mx plus b format, I can now graph that. First one, y equals negative 2x plus 14. I'm just going to extend this a little bit further. So 10, 11, 12, 13, 14. So this would be our 14 here. I'll put a point here, and it has a slope of negative 2. So it means if I go down 2 to the right one, down 2 to the right one, down 2 to the right one, so on. My line would look something like this. Then I'm going to use blue for this other one. So I put a point at positive 1, slope of 3/5, so it goes up 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. And if I draw a line here, we can see that it right here, trying to figure out what that would be. You can see mine is off a little bit, and the reason why mine is off is because I actually numbered this one wrong here. So 14 would actually be right here. So I'm going to erase this blue. The blue line is correct. The green line is off a little bit, so let me go back to this one again. So down 2 to the right one, down 2, 1, 1, 2 to the right one, down 2 to the right one, down 2 to the right one, down 2 to the right one. So here, So this would be 5. Going across would be 4. So this crosses in one solution. So we have one solution. And the solution would be 5, 4. You can see if you're not as accurate when you're drawing it out, it's easy to make a mistake. So here, just going back to what I had there, I can verify that I put them in the right spots. I know that for the most part, yours is going to have to end up on one of these corners. If it doesn't, you know you did something incorrect. Next one, y equals 1/4 x minus 5 and y equals 1/4 x plus 3. Here I know that there is no solution. And how do I know that without graphing it? My slopes are the same. But I'm just going to graph them anyways, so we can prove that. So -5 on the y-axis, and go up 1 to the right 4, up 1 to the right 4. My line would go like this. And the other one, put a point at +3, goes up 1 to the right 4, up 1 to the right 4. And my line would look like this. So you can see that the lines are parallel. Next, graph the system, and then we need to determine the solution if there is a solution. I need to put this in y equals mx plus b first. So I'm going to add 3x. So now I have 5y equaling 3x plus 10 divided by 5. I now have y equals 3/5 x plus 2. And then the other one, add x to both sides. Now I have -5y equals x minus 10 divided by -5. I would have y equals -1/5 x plus 2. So now let's plot them. So I'll plot the red one first. So I put a point at 2. Slope of 3/5, so up 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. I'm going to go down 3, 1, 2, 3, to the left 5. And then I'll draw my line here. And then the other one, put a point at 2. Has a slope of -1/5, so down 1 to the right 5, 1, 2, 3, 4, 5. Or I can go up 1 to the left 5, 1, 2, 3, 4, 5. And draw my line here. We can see that they cross in exactly one spot, and that one spot would be 0, 2. Let's graph this and solve the system of equations here. Then we're going to put in y equals mx plus b. So this one, to rewrite this, would be y equals, I had to add 3x and then divide by 2, so that would be 3/2 x plus 13 divided by 2 would be 13/2. You can think of this as 1.5 and 6.5. And the other one here, rewrite this one, it would be y equals, I subtract 6x, and then divide by -4, which would be a positive 3/2 x. And 8 divided by -4 would give us a -2. So if I plot these on my graph here, so I have 6.5 on the y-axis, so 6.5 would be roughly here. And then I go down 3. Actually, yeah, I'll go down 3. So 1, 2, 3 to the left. To the left 2. So 1, 2. So I'd have a point here. Down 3 more. 1, 2, 3. To the left 2. 1, 2. Then draw my line. And the other one, put a point at -2. Slope of 3/2, so it goes up 3, 1, 2, 3 to the right 2, 1, 2. I go down 3, 1, 2, 3 to the left 2, 1, 2. If I draw my line now, you'll see that they are parallel, so there is no solution. Next, graph this system. First one here, gonna divide everything by -1, so that would be a negative x plus 5. And this one would be going to add 1/2 and then multiply everything by 5. So that would be 5/2 x minus 2. Now if I graph them, the first one, put a point at 5, slope of -1, so down 1 to the right 1. And draw my line. The other one, put a point at -2 and go up 5, 1, 2, 3, 4, 5, to the right 2, 1, 2, up 5, 1, 2, 3, 4, 5, to the right 2, 1, 2, and draw our line here. That's not a good line now. We can see that it crosses here, which is at 2, 3. So our solution would be 2, 3. And if you want to just double check that, you can put a 3 here and a 2 here. This would give us a -3. 2 minus 5 is -3. If you put a 2 here and a 3 here, you would have -1 plus 3/5, or think of this as -5/5 plus 3/5 will give you -2/5, which matches up with that. So our solution is 2, 3. Example 4, write a system of equations from a word problem. It says China and India are the two most populous countries in the world. Populations of these countries have increased steadily in recent years. In 2010, China and India had populations of about 1.34 billion and 1.19 billion, respectively. By 2016, the population had grown to about 1.38 billion in China and 1.29 billion in India. Predict the approximate year when the populations of the two countries will be the same. Write a system of equations and then use the graphing calculator to solve. So this will be easier to put on our calculator, but the first thing we need to do is come up with our equations. So to come up with our equations, we need to find our slope. So to find our slope, we need our 2 points, and our 2 points are going to be the year. So we're going to do 2010, and for China in 2010 they had a population of 1.34 billion, and then India in 2010 had a population of 1.19 billion. And the other equation we'll use is 2016 numbers. 2016, China had 1.29 billion, and India in 2016 had China in 2016 was 1.38, and India was 1.29. So those are our 2 points that we want to use. We want to go from one point to the other. So this would be China, India, China, India. So we want to do 2 lines. One is dealing with China's increase, and the other one's with India's increase. So we're going to take the 2000 for China. We're going to do a point change in their y, so 1.38 minus 1.34. Divide that by 2016 minus 2010. And this is going to give us, as a fraction, be 1 over 150. Now you don't want to put it as a decimal because it's going to give you a repeating decimal. And if you put it as a repeating decimal, or put it as a decimal, or round it a repeated decimal off, then it's going to change your actual slope. So you want to put it as a fraction. Then the other one, you're going to have 1.29 minus 1.19. So we're just using India's here. This will be divided by 2016 minus 2010. And we get a slope of 1.29 minus 1.19. Divide that by 6. Gives us 0.016 with the 6 repeating. I'm going to change that to a fraction, which would be 1 out of 60. Then we're going to use what their starting point would be and what their predicted here when the population is two countries will be the same. So you're going to go with the rate to your slope, and then we're going to use what they did in what the population was in 2016 for their starting point, because we're looking at for the future. So for China, we're going to have an equation of y equals 1 over 150 x plus, and they ended 2016 at 1.38. And then we're going to do India's, which will be y equals 1 over 60 x plus, and in 2016 they had 1.29. Now I'm going to grab my calculator and we're going to put those in our calculator to graph them. So I'm going to hit the y equals. I want to turn my plot off to make sure that's off. So I just go up there, hit enter, clear what I have in here, and then I'm going to do parentheses 1 divided by 150 and parentheses x plus 1.38. That would be one equation. My second one would be parentheses 1 divided by 60 and parentheses x, and then it would be plus 1.29. Now if I hit zoom, I'm going to go to standard, so it's number 6. There's one equation. Then the other one is still mentioned there, but we need to change our Windows settings. So since we're only going to deal with positive numbers, I'm going to hit the x's minimum is positive. The max, let's just choose this one at, I'm going to make that 100 just to make sure, and then we're going to count by 20s. My y, 0, we're going to get that by, I'll make that 100 as well. We'll count by 20s. We'll just guess to see what we have. That way we might have, you can see we're a little bit to there. We might need to change our Windows settings a little bit. So let's change the X maximum. I'll keep that one there, but let's do the Y minimum or Y max. Let's just make that, let's make that 5. And then we'll count by 0.5. And maybe that will be a little bit easier to see. Okay, let's change our X's, so the Windows, change our X's to, let's do the max, let's do that one by 5 and then this one by 0.5. Let's see, that one is a little bit harder. So let me change the X, let's make this 20. Count by ones, and then try that. Okay, so we know that it crosses somewhere in here. So now if I take second trace, and we want to find out when would the two countries be the same? So we want to find the intersection points. So we're going to choose number 5. First curve, hit enter. Second curve goes to the other line, hit enter. I hit enter a third time. It's going to tell me the coordinates at 9, 1.44. So what that tells us is after 9 years after 2016, they will both have the population of about 1.44 billion people. So we have to say when will they, approximately what year would that be? So if I do 2016 plus the 9 years, that would give us 2025. So the year 2025 is when they would be roughly the same amount. Next, 2 ride-sharing companies charge customers a base fare and then an additional fee per mile. Ride Around charges a base fare of $3 and $1.25 per mile. Cargo charges a base fare of $7 and $1.25 per mile. Write a system of equations that describe the total price of a ride for each rideshare company and use a graphing calculator to graph and solve. So the first one, the ride along, this would be y equals, it's $1.75 per mile, so that's 1.75x plus a base fee of $3. You have to pay that 3, and then cargo would be y equals $1.25 a mile plus a $7 base fare. So those would be our 2 equations. So now if I come back here, grab our calculators, go back to our y equals, clear everything that I have, and we're going to put 1.75x plus 3, and the other one would be 1.25x plus 7. And then I'm going to hit zoom. I'm going to go to standard again, 6. There's one line. Here's the other. We can't see where it crosses. I'm going to change my Windows settings. So I just have to increase my Y maximum. So let's just do, on the safe side, let's just do 30. And then let's see if that shows. Okay, it shows over here. So again, we hit second, trace, intersect number 5. First curve is one line, second curve is the other line. Yes, and it tells us 8 and 17. So if we go back to our question, it says, write a system of equations that describe the total price of ride-sharing. Use a graphing calculator to graph and solve. So we had 9 and 17, or 8 and 17. So what would that mean? That would mean after 8 miles, they both charge $17. Next, the number of men and women participating in Winter Olympic Games has been steadily increasing in recent years. In the 19th Winter Olympics, 1,389 men and 787 women participated. In 1960, men and 1,121 women participated in the 22nd Winter Olympics. What we want to do is write and graph a system to describe the number of men and women participating if X represents the number of Winter Olympics after the 22nd Winter Olympics. And then part B, use the graph to predict the Winter Olympics when the number of men and women participating will be the same. To go back, we're going to write our equations here. So our Y's are going to be participants and our X is Olympics. So the participants, we're going to do the men first and then the women the next equation. So the first equation, we're going to have y, actually we have to find the slope first. So we'll be doing 1660 minus 1389 divided by, there were 3 Olympics in between because there have been 22 minus 19. So if we do that math, that gives us as a fraction 271 divided by 3. And then the other one we would do for women 1121 minus 787 divided by 22 minus 19, which will give us 1121 minus 787. Divide that by 3, and we get 343 or 334 over 3. So now we come up with our equations here, and this is after the 22nd one. So our equation would be y equals 271 thirds x plus, for the men, they had 1,660 in the 22nd Winter Olympics. And here for the women, we'd have y equals 334 divided by 3x plus women in the 22nd Olympics was 1121. So now we're going to get our calculators and we're going to put those equations in. So first off, parentheses, 271 divided by 3, end parentheses, and then we'll put our x, then plus 1660, and the other one would be parentheses 334 divided by 3, and parentheses x plus 1121. Now I'm going to change my Windows settings. So I know we're going to have a 0 for our minimum. Our max, our x max, let's just do 20 and we're going to count by 5s. The minimum for my y is 0. My max, let's do 5,000 and we'll count by 1,000s. And we hit graph. There's our first one, that's the men's. Here's the women's. Okay, we can't quite see where they cross. I have to extend my x's. So let's count this by, let's do 50. So again, here's the men. Here's the women. Crosses here. So hit second, trace. Intersect, number 5. Enter. Enter 3 times. And it tells us 25.6. So after 25 Olympics, they will both have about 3,978 participants. I go back here, we did write our system and we did graph it. Now we have to predict the Winter Olympics when the number of men and women will be the same. So we said it was like 25.6 Olympics. So if we were on the 22nd, and we could round that, so we had like 25.6, and then the y's was, so let's do estimated. So that would have been about 26, and our y's would be 3,979. 3,979. So that means there's 26. So after the 22nd Olympics, I add 26 to that. That would be the 48th Olympics, when they would both have the same amount, which would be 3,979 participants. Next, use a system to solve these linear equations. So it says use a system of equations to solve. So we have two equations here. So this first one, each side of the equal sign is going to be a separate equation. So we're going to have y equals negative 6x plus 8 and y equals a negative 4. And this one I'm going to put on the coordinate plane here because that would be a little bit easier to do here. I'll point at 4, and this is going to go a horizontal line across this here. The other one, we're going to do positive 8 has a negative slope of 6, so down 6. 1, 2, 3, 4, 5, 6 to the right one. 1, 2, 3, 4, 5, 6 to the right one. So our line would be here. So our solution would be 2, negative 4. Now this other one, we'll use our calculator for it because that'll be a lot easier, especially with the decimals involved. I'll go to my y equals, clear everything. On the left-hand side, I have 1.5x minus 9. And the other one would be a negative 4.1x plus 5. And then zoom, number 6. There's one equation, there's the other. We want to find out where does they meet. So I hit second, trace, number 5 for intersect, hit enter 3 times, and it tells us 2.5 and negative 5.25. So 2.5 and a negative 5.25 would be our solution. Next, use a system of equations in your graphing calculator to solve these. It says round to the nearest hundredth if necessary. So I'm going to y equals negative 3.2x minus 5.8, and we have y equals 0.8x plus 7. We'll grab our calculators again. Go to our y equals. We'll just edit this a little bit. So negative 3.2x minus 5.8. And this one we have 2.8x plus 7. And graph this one. Here's our first line. Here's our second line. Crosses here. So I'll hit second, trace, number 5. Hit enter 3 times. Gives us, now it says to the nearest hundredth, so 2 decimal places. So that's a negative 2.13 and a 1.03. The other one was 1.03. And that would be our solution. Next, Bill is starting a food truck business to sell grilled cheese sandwiches, or gourmet grilled cheese sandwiches. He has spent $34,000 on the truck, equipment, permits, and other startup costs. Each sandwich costs about $1.42 to make, and he sells them for $7. Given these constraints, how many sandwiches does Denzel need to sell to start earning a profit? So we need to come up with two equations, one for the cost and one for the revenue. So for the cost, we have y equals, the cost is $1.32 per sandwich, plus he has the $34,000 he spent to start the business. The other one, the revenue is he's selling it for $7 per sandwich. So those are going to be our two equations. We're going to use our graphing calculator to solve this one. So x is the number of sandwiches, y is the total cost revenue. So again, here we have our two equations, one for total cost, one for revenue. We're going to type those into our equation, or our calculator. So I'll grab our calculator here, our y equals. Clear everything I have. And we have 1.32x plus 34,000. One too many zeros. And the other one, 7x. Now my windows, I'm going to have to change this a little bit because I need to get my y. My minimum is going to be 0 because I can't have that. My max sandwiches, let's just do, I'll do a conservative amount. I'll just say 500. We'll count by 50s. The minimum, y minimum is 0. The maximum, I have to get at least 34,000. So let's just do, I'll make that 50,000. And we will count those by 10,000. Now let's hit graph. There's one equation. There's the other. I'm going to have to change my y's more, so, or my x maximum. So let's make this 10,000 and we will count by 1,000. Let's try that one. There's one equation, or one line, there's the other. Now if I hit second, trace, number 5, hit enter 3 times, you'll get what we have on the screen here. So about 5,986 sandwiches, and they would bring in a profit of $41,901. So to solve this one, we found the intersection points. So x is roughly 5,986 sandwiches, and our y is roughly $41,901.41. So he would have to sell at least 5,986 sandwiches to make a profit. Now you can't sell part of a sandwich, so that's why we'd have to round this to the whole number. And our last question, giraffes stand about 6 feet tall when they are born. Suppose a male giraffe is born at 5.7 feet tall and grows 1/12 foot per day. A female giraffe born a few weeks earlier is 6.8 feet tall and grows 1/16 of a foot per day. Let x be the number of days and let y be the height of the giraffe. How many days will the two giraffes be the same height? For this one, we need to come up with our two equations. Our first equation for the male giraffe would be y equals 1/12 x plus 5.7. And then the female one would be 1/16 x plus 6.8 feet. We're going to use our calculators again, so I'll grab our calculator, go our y equals, clear everything, go back, and we have parentheses 1 divided by 12 x plus 5.7. The other one would be 1/16 x plus 6.8. Then if I hit zoom, number 6, here's one equation. Here's the other. Can't quite see it, so I'm going to have to change my settings, change my x maximum. Let's do that 50, count by tens. That one should show the 2. Okay, roughly there. So we can do second trace, number 5, hit enter 3 times, and it tells us. Okay, let's go back to our Windows setting. Let's change this to 100. Count by 10 still, and then try this. And I'm going to change my y maximum. This minimum will change to 0. the max, let's do this to 20, then hit graph. Okay, second trace, number 5, hit enter 3 times. Gives us 52.8 and 10.1. So about how many days will the two graphs be the same height? 52.8 days. Or you could say about, so this would be exactly 52, or about 53 days. That is our lesson on solving systems of equations by graphing.